Point-slope form is the last form that you're going to learn for linear equations. Quick review, we learned how to graph a linear equation using a t-chart, plug in values of x, find y. That was the first way. We learned that in chapter 4. You also used that last year a lot. Second way we learned was slope-intercept form, and that was y equals mx plus b. You graph using your y-intercept and then your slope. Third way, standard form or intercepts, was ax plus by equals c. That's when x and y were on the same side of the equation, and you plug in 0 for x to find your y-intercept, 0 for y to find your x-intercept. And then the fourth way is called point-slope form, and this is what an equation in point-slope form looks like. Y minus y1 equals m times x minus x1. x1, y1, those little subscripts there, are meant to show you that that's your actual point you're given or you're taking from a line. It's a point, one point on the line. There's going to be several different options for those points sometimes, but it's one of them. X and y are the variables, the x and the y with no subscript, and m is your slope. The most common mistake that I see with this, right here with the point, do you see how you have a negative, a minus? When you have a negative here, it's one of the few times I'm going to say ignore it, because you actually are pulling out the opposite right here of what you've got. So if this was a negative 3 and this was a negative 4, you would pull out positive 3 and positive 4 for x and y. Sorry, I mixed that up. If it was a positive 3, then you would actually pull out a negative 4, because negative negative gives you positive there. So you have to think opposite signs, which is a really common mistake when you're pulling that point out of your equation. One of the reasons that I don't always recommend you use this way unless you're really good at memorizing those little things like that. So copy this down. I'm going to write about that little common mistake here also. So I just made a little note there. Keep an eye on your x1, y1. When you're taking x1 and y1, it's always going to be the opposite sign of what you saw in that formula. Example 1 asks you to graph y minus 5 equals 1/2 times x subtracting 2. So you should get good at noticing point-slope form. There's a y, subtracting a number, equals slope times x subtracting another number. So that's already in point-slope form, which means you can graph it using point-slope form. And this is how you're going to graph it. You take your m, your slope, just like slope-intercept form, m equals 1/2. But then, instead of finding a y-intercept, you're just going to find your point. And remember, your point is the opposite, so don't include the sign. The point is, that's my y1, that's my x1. So x first, positive 2, y second, positive 5. Now, slope-intercept form, you plotted your point, or you plotted your point on your y-intercept, and then you counted out your slope. Instead, you're going to plot your point on the point that you found and then count out your slope from there. So go ahead and draw your coordinate plane and then we'll graph it. So when you go to graph it, you're going to start at your point. So over 2, up 5, that is my starting point right there. Now look at your slope. Up 1, right 2. Up 1, right 2. Up 1, right 2, up 1, right 2. Now that I see that pattern, I can go down 1 and left 2, down 1 and left 2 if I want more points to be able to connect. And that's all you're doing. So if you understand graphing with slope-intercept form, This is exactly the same other than the fact that you're not plotting a point on your y-intercept. You're plotting an actual point that you find from there. And then you just have to remember that rule about the opposite sign when you pull out the x and the y. Get a straight edge and connect that. And that's what your graph should look like. So all of these are possible solutions of that linear equation that's in point-slope form. Now, let's just say that you forget the rules that go with this, or you feel like you're doing something wrong, or you forgot where slope is in here. Something happens. You can always go back to converting equations. You know slope-intercept form, and it's really easy to get slope-intercept form from point-slope form. So we're actually going to practice that tonight with all of your problems and tomorrow, because I want you to get really used to going between point-slope to slope-intercept to standard form. You should be able to convert between those three with no problem at all. And that's all Chapter 2 practice. So make yourself a little note, if you need to, that says start here. So you remember that's where you're always starting when you graph those. And then up here we're going to just write, when you're graphing, start at the point and then count out your slope. Start at the point given, then count slope from that point. Now we're going to practice converting this to slope-intercept form just so that you get used to it right now. I'm going to go ahead and convert it in red. So I'm going to put converted to slope-intercept form. So you take your original equation, y minus 5 equals 1/2 times x minus 2, and you just simplify this. You're isolating y. So first thing you should always do, hopefully you all noticed right there, is distribute your 1/2. So you end up with y minus 5 equals 1/2 x minus 2 times 1 is 2 over 2, which is 1. Now you're still isolating y, so you're going to add 5 to both sides. Always line up like terms when there are like terms. You end up with y equals 1/2 x minus or plus 4. Now you have slope-intercept form. So from here, you can take m, which is 1/2, notice it's the same slope as you had before, and b, which is 4. And if we think of that b as a 4, it's like saying 0, 4, point-slope form. Plot the point 0, 4, count out the slope. So it's almost exactly the same. And I want to show you what should happen with these. This, starting at 4 and then counting out my slope, should give me the exact same line on my graph. So let's go up there and try it. I'm starting at 4 on my y-axis. 1, 2, 3, 4. Notice the points are already matching. Up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Down 1, left 2. Down 1, left 2. And notice you get the exact same line. Okay, that should have happened that way because you're graphing the same equation. The equation hasn't changed. It's the same equation that you originally had. The only difference is that it's in a different form. And that's why using any of the 3 ways to graph that you've learned, well now 4 ways, you can really use those anytime as long as the equation is in the correct form to use it. And you'll get the same answer. Go ahead and write this down. Once I'm done talking, you can just hit pause, copy it, and then hit play when you're ready to go. The next example we're going to look at is writing an equation in point-slope form when you're given info. So you're going to have to memorize point-slope form if you're going to use this. All you do is take the given info, plug it into the equation, and you watch for double negatives. So go ahead and write this example down, and then when you're done, hit play. Again, in order to do this, you're going to need to make sure that you actually write or memorize the equation. So equation y minus y1 equals m times x minus x1. Your given info is right there every time. You should always have an x and a y. This is your m, x, and y. So you just rewrite it. Y minus, remember, that subtraction is all by itself. Now you go plug in your y value. So I would use parentheses. Times -3 times x minus a -1. So you have a double set of parentheses there, but that's okay because you're going to fix that right away. This stays negative, so I just have y minus 7 equals -3 times x, double negative here, plus 1. That's in point slope form, and you're done. You have your equation written. Now, if I asked you to convert it to slope-intercept form from there, try that. And hit pause and try it on your own, and then hit play when you're ready to start. Remember, you don't always have to convert them to slope-intercept form. I just want you to be really comfortable with converting between the different forms. You're going to learn how to write equations using point-slope form, but then I'm also going to be showing you a way to write equations using slope-intercept form. It's always been easier for me to write it using slope-intercept form because it's less for me to memorize and think about with these double negatives that show up sometimes. But every year I find some students who really prefer point-slope form and do a really good job with it. So it's going to come down to what you're more comfortable with in the end. So I'm showing you both ways, and then you're going to kind of start figuring out what works better for you. So if I was going to convert this to slope-intercept form, first thing I would do is distribute my -3, and I'd end up with y minus 7 equals a -3x minus 3. Be careful with those negatives. Now I would move 7. I end up with y equals a -3x plus 4. That's slope-intercept form. M is -3, B is 4. Notice you have the same slope. That's going to happen every time on those. It's just the point that changes because here it's any point, here it's your y-intercept. And again, if I graphed this, or this, and this on the same line, or on the same coordinate plane, I would have the same exact line. It's not going to change what my line looks like in the end. Now I'm going to walk you through writing an equation in slope-intercept form. And I'm going to use the exact same example that they gave us for example 2. But we're going to start it and just start it in slope-intercept form. So again, example 2 and the one I'm going to show you right now are two ways of doing the same exact thing and getting the same exact equation in the end. But we're going to be writing it in slope-intercept form instead. Remember, slope-intercept form is y equals mx plus b. All you're going to do is plug in your given info and then solve for b. You're going to find that you're given a point, x and y, and m, but not b. And remember, we always need an m and a b to have a linear equation in slope-intercept form. Then you're just going to rewrite your equation with m and b as your numbers, and you're going to leave x and y as your variables. So hit pause, write that down. Once you're ready, hit play and we'll go through the example. So example 2 is the other way of doing example 2. I'm keeping it as example 2 on purpose. Y equals mx plus b form. Your slope is -3, your point is -1 and 7. It's the exact same example we just did, but I'm going to show you how to set it up in slope-intercept form. All you're going to do is take, when you're thinking about y equals mx plus b, you have m right here, and they gave you a point, an x and a y. So you have x and you have y. You're going to plug those in and find b. So here's my y. 7 equals m, which is -3, times x, which is -1, plus b. 7 equals 3 plus b. Subtract 3 from both sides, and now you have your b. And you rewrite your equation. M equals -3. That was already given to you. And your b. Exactly like we were doing the other day when you were given an m and a b. So y equals m x plus b, and you're done. Y equals -3x plus 4, which is exactly what we got when we converted point-slope form to slope-intercept form on the first set of example 2. So either way works. I'm okay with either way. I will tell you that most students choose this way because it saves you from memorizing point-slope form. But you need to be comfortable with both. Practice it both ways. The homework today and tomorrow, or the class assignment, is going to be switching between both ways until you get pretty comfortable with both and find what you like best. Go ahead and write example 3 down. Example 3 says to write an equation that contains 2 points. So now instead of being given slope and a point, you're given 2 points. The only thing that happens here is you're adding one step. So you need to stop and think about, oh yeah, that's right. I can use 2 points to find slope. Once you have slope, you have m and you have a point. Or you have m and you have a point. You don't need both points once you have your slope. You get to pick which one. That's the only added step. If you were to go back and look at example 2 right now, and you were to find slope using the formula we've talked about, once you have that slope, you just pick one of these points. I would probably pick that one. You plug it in, and you find your equation. So nothing really new here. It's just adding things you already know. So we're talking about first writing an equation when we're given 2 points in point-slope form. Again, I'm going to show you both ways. I'm going to show you point-slope form, then we're going to do this exact same answer using slope-intercept form. All you do, like I said, take your 2 points and find your slope. Once you have m, pick one of these 2 points to be your x1, y1, plug it into your equation, you have your answer. You have your equation. And then from there, you could convert it to slope-intercept form if you wanted. So go ahead, finish writing that down. Once you're done writing it, hit play and we'll go through the example. All right, so first thing I'm going to do is I'm going to find my m. M equals 3 subtracting a -5. Because I chose 3 first, I have to choose 2 first. 2 subtracting a -1. This ends up being 3 plus 5 over 2 plus 1. Which is 8 over 3. So now I have m equals 8 over 3, and then point, again, you choose. It really doesn't matter. It's completely up to you. I'm going to go ahead and pick this as the point because I want you to see it when we have to be aware of those negatives again. I want you to practice being aware of those negatives. So I'm going to go ahead and pick the point -1, -5. Someone else might have picked the point 2, 3. They end up with the same equation in the end. So now I have to think about point-slope form. Y minus y1 equals m times x minus x1. I'm filling in y1, m, and x1. Y minus -5 equals 8 over 3 times x minus negative 1. I end up with y plus 5 equals 8/3 times x plus 1. Okay, now someone else might end up with something a little bit different here, but if they were to graph that equation, they'd get the same thing. They might plug in the point 2, 3. They would have ended up with y minus 3 equals 8/3 times x minus 2. But once they graphed it, they'd have the exact same line. Okay, so I'm going to put converting. Now we're going to practice converting. Convert to slope-intercept. Y plus 5 equals, I'm going to go ahead and distribute right now, 8/3 x plus 8/3. Because I don't like fractions, from here I'm going to use a fraction buster. So I have y plus 5 equals 8/3 x plus 8/3. And I'm going to go ahead and multiply every term, remember every term, by 3. So 3 times 3 times 3 times 3. I end up with 3y plus 15 equals 8x plus 8. Now I subtract 15 from both sides. 3y equals 8x, and then subtracting 7. Now I divide every term by 3. So your final equation is y equals 8/3 x subtracting 7/3. Again, if it asks you to write it in point-slope form, you're done there. But if it asks you to convert it to slope-intercept form, you would have to do this. Or if you wanted to convert it to slope-intercept form to graph it or to do something else with it, then you would have to do all these steps. I'm not telling you every time you have to do all of that. Go ahead and write this down. As soon as you're done writing it down, hit play and we'll go through the example. Alright, so when you're writing an equation and you're given 2 points using your slope-intercept form, again, we're back to y equals mx plus b. You need m and you need b. All you have is 2 points. You have an x and a y, you have an x and a y. But you know you can use those points to find m. Once you have m, one of these points could be x and y, you can find b. We're right back to that other example. So first you find m. I'm going to go ahead and have negative 5 minus 3 this time. Negative 1 minus 2, subtracting 2, is a negative 8 over a negative 3, which is 8 over 3. Same slope as last time. Should happen every time that way. Now choose a point. You choose it. Let's use 2, 3 this time. Okay, this is y equals mx plus b. I have x, I have y, I have m. There's my y, there's my x, there's my m, I need b. So I'm going to plug everything in to find b. 3 equals 8 over 3 times 2 plus b. 3 equals 16 over 3, I just multiplied 8 times 2, plus b. If you don't like fractions, you can use a fraction buster. This is a quick, easy fraction buster. We have 3 equals 16 over 3 plus b right here. Just make sure every term times 3 times 3 times 3. My 3's there are going to cancel. That was the whole purpose of it. 9 equals 16 plus 3b. And now I'm just solving for b. Subtract 16. You get negative 7 equals 3b. Divide by 3, and you have b. So b equals a negative 7/3. And you already had m. M equals 8/3. So now you get to write your equation. Y equals m x plus b, but in this case minus 7/3. And that's in slope-intercept form. If you go back and look here, slope-intercept form, exact same equation. So you'd get the same line either way you decided to go ahead and find these equations. Copy that down. It's just saying what we did. You're finding m using that formula we know. Use m in one of your points, doesn't matter which point, to solve for b. Once you have b, rewrite your equation with x and y as your variables. M and b should be numbers.